Hey guys, for those of you coming from my last video, which was about the fundamentals of statistics, this video is going to kind of tie into one concept we brought up last video, which was categorical and quantitative data. So what chapter 2 focuses on is how to take categorical data and then visually represent it. So this is mainly just a bunch of graphs. You'll see your bar charts, your pie charts, your tables here. So a couple things you have to remember when making a graph is to always title your graph, label your axes, and then when necessary, you'll need to make a key or a legend. So that's one thing. The other one is there's this rule called the area principle. So what it says is basically that the information in your graph cannot be portrayed in a misleading way. So if you put 3D edges on the backs of your bars in your bar charts because you want to be extra, that violates the area principle. And it's the same thing with misscaling or purposely cutting off parts of your y-axis to make the bars look shorter than they should be or taller than they should be. So our first kind of categorical representation is your frequency tables and your relative frequency tables. So this is just your generic table when you have one group of categories and then some numbers per each category. So if we went around in some class here, and then we asked each person what their favorite color was, if we get 3 red, 6 blue, 2 yellow, 3 green, 6 purple, then we could put it in a table like this. So in our first column, we've labeled it with what our variable is, so color, and then frequency is the number of times it showed up. So the number of times people chose this color as their favorite color. And this brings up another important concept, which is frequency versus relative frequency. So frequency is just your straight up counts. So if 3 people liked red, then your frequency is 3. However, relative frequency is a little bit different. You're taking your counts and you're changing them into percentages. So that's what the relative means. When you see relative frequency, you know that everything is in percentages. So that's what we have over here. Instead of counts, we have changed our 3 into a 15% out of everyone. So in total, there were 20 people interviewed here for this table. And because 3 people liked red, then 3 out of 20 people liked red. And if we change that into a percentage, that becomes 15% of people who have chosen red as their favorite color. So next we have a more visual representation, which is your bar chart and again your relative frequency bar chart. And this is just your generic bar chart where you have your categories at the bottom in your x-axis, and then the number of times that category shows up in your y-axis. And there's one thing, if I was a teacher, I would definitely take off points for here, is that the x-axis on both of these are not labeled. You have to label color here. Your graph could be perfectly fine, but if you forget to label axes, you're screwed. So you'll notice the first graph says on the y-axis that it is frequency, and in the second graph it says relative frequency. So because it says relative frequency, all of the numbers on the y-axis have become percentages. So you'll see 0%, 5%, 10%, but on this one over here, it is your straight up counts, so 2, 4, 6, 8, 10, 12. However, even though our axes look a little bit different, if you look at the graph itself and ignore all of the labels on the axes, you'll see that the graphs really do look the same. And they are the same. You're just reducing it by some scale factor, but the bars in comparison to each other will look the same. So this is another variation of your bar chart, and this is used when you have a variable inside of a variable. So earlier for our color example, if we went and asked each person, what is your favorite color? And then if they say red, then we split red into 3 more categories. Do you like dark red, light red, or generic red, I guess? So that is when we would use a side-by-side bar chart. So here, this is for the Great Lakes gross state product. We have the big categories as state. So Illinois, Indiana, Michigan, Ohio, Wisconsin. But then each state has been split into 3 subcategories by year that we got data from. So 1998, 2001, and 2004 as labeled up here. And this is when you'll really need to use your key. so that people know which bar means which subcategory. So your blue bar means the subcategory of 1998 gross state product. Your y-axis still remains the same, and you could change this to relative frequency anytime you want. So next we have yet another variation of your bar chart, which is your stacked bar chart and your segmented bar chart. First of all, there's a lot of things wrong with these charts. I'm only using this for demonstration purposes, but it is really not a very nice chart. First thing you're missing is a title and then axes labels. Instead of putting the bars with their butts on their x-axis, it's instead on the y-axis. So here, your bars are vertical, here they're horizontal. You can definitely do this, there's nothing wrong with it. It's used a lot when your category names are kind of long, so then you could just write them horizontally here, you'll have more space. That's not anything that's wrong with the charts, but what is wrong is that this axis needs to be labeled with either frequency or relative frequency, and then the names of the categories should also be labeled. What the stacked bar chart and segmented bar chart are is basically a variation of your side-by-side bar chart. Now, instead of the bars in the subcategories being side by side, we took the orange bar and put it on top of the blue bar, and then we took the gray bar and we put it on top of those. So we've put them all on top of each other, and there comes the name stacked. Oh, we're also missing a key, by the way. So what we would do is we have some big category over here. Let's say it's state again. So Texas, Ohio, New York, California. And then inside of each state, they have more subcategories of data. So if we went by year again, we could say 2001, 2002, 2003, and 2004. And these would be our subcategories. So now we've taken the frequency for each year and we've stacked it on top of each other. So this first one was called the stacked bar chart, and our next one is called the segmented bar chart. This one, it sounds different, but it's really not. It's just a fancy way of saying that this one is a stacked bar chart, but instead of frequency, we have changed it to relative frequency. So now if we look at the x-axis, in the first chart over here, these are all counts. But in our second chart, they're all percentages. So that is where our relative frequency comes in, and that is why we call it segmented. And one main difference that you'll notice between the two is that in bar chart number 1, all of the bars are different lengths. In bar chart number 2, they're all the same length because everything always needs to add up to 100% or else we're missing some data. Next we have our pie chart. You don't have to make these as much because they're so hard to eyeball when you make them. But the one thing you need to keep in mind is to keep your percentages constant and to label everything. This one is missing a title. This one is not, but this one has its own problems we need to talk about. You'll notice that they've added some 3D effects to this one, so the pie chart now looks kind of tilted. Even though our stock slice looks really small in comparison to our bond slice, right? Because the pie chart has been tilted on its side. However, if you look at the actual percentages, this one says 4% and bonds is actually smaller. It should be 3%. So because the stocks look smaller than it should be and the bond slice looks bigger than it should be, this one is violating a rule that I mentioned earlier, which is the area principle. Because this one is misleading in terms of its areas that it's portraying, this one is not a good pie chart. Next, we have our contingency tables, which are also called two-way tables. So this is when we have multiple categories that we're putting together. So here, our top category would be pets, and then our horizontal category would be gender. So the way you read these is first we have people that like dogs and are male, then are male and like cats, and then we add them all up in our total columns in our total row. And then our final number of people in all will be in the bottom right corner, always. The information in here is what you'll look for when people ask how many people like dogs and are male. So another thing that they'll ask about these is how to describe the distribution of these tables. So the first thing that they'll ask is conditional distribution or marginal distribution. And these two have some fundamental differences, but the way you talk about them is basically the same. So the place you look for when you look for your marginal distribution, okay, let's think. What does margin mean? If you have a piece of paper, you always notice that in notebook paper there is a margin on the side, right? So your margin is kind of your border. So coming to our table, we have our borders here on the outside. These are our border numbers and these are the margins of the table. So this is marginal distribution. And they'll ask you for either the column or the row. So the way they'll ask here would be, what is the marginal distribution of gender, or what is the marginal distribution of pets? Marginal distribution of pet preference, that would be at the bottom, because at the bottom the table has been split into dog and cat. But if they ask for gender, you come up here because it has been split into male and female. That is marginal distribution, and it is on the bottom here. The way you would write it is you state how many people out of the total are either male or female, and then you have to give a percentage. So I know it sounds kind of tedious, but you need to show your work here, and that is what the little phrase in parentheses is, the 48 over 100 and the 52 over 100. That is your work, and that shows your math. Because, again, stats is more of a writing course than a math course. You need to show where you're getting everything from. Next, we have our conditional distribution. So for conditional distribution, you now look on the inside. So you look at these boxes over here. And what they'll ask is either for this, or these two columns. So they'll likely ask something along the lines of, what is the conditional distribution of male pet preference, female pet preference, or what is the conditional distribution of people that like dogs' gender, or what is the conditional distribution of the gender of people that like cats? So how do we deal with that? So they will always give you a category name, which is the name of the row or column that you'll be looking at. So what is the conditional distribution of males' pet preference? So they said males, right? So that is over here, and that means that we'll be looking at this row. So we're taking the male category and we're telling people what is the split in men between dogs and cats. And if they asked instead about the difference in gender between people that like dogs, so you would look at the dog column and you would take all of the people that like dogs and split it into male and female. So the way you would write that is the conditional distribution for male pet preference, and then 42 out of the 52 males, show your work, like dogs, and then 10 out of the 52 males like cats. So that is your conditional and marginal distribution, and it's a lot of writing, but it's good stuff. So when two variables are independent, it basically means that one should not affect the other. In a table, what would that look like? So it basically means that no matter whether you are male or female, if these two variables are independent, then the percentage of females that like dogs should be the same as the percentage of males that like dogs. So how would we get those numbers then? So there are many ways you could check for independence. 52 out of 100 people are male, right? If these two variables were independent, the percentage of males that like dogs and the percentage of males that like cats should be the same as the total number of males in this study. Because if they were independent, then if 15% of the people are men, then 15% should like dogs and 15% should like cats, because there's no correlation or relationship between the two variables. Let's see if that's true. So we have our 52 and our 100, so our 52%. And we want to see if this percentage holds true for the split between dog and cat. So if we go into the dog column, 42 out of 51 dog lovers are male, so let's put that down here. Then in our cat lovers, we have 10 out of 49 people are male. So 10 out of 49. I don't even need to put this into the calculator because I can already see that this is way greater than 1/2 and this is way lower. And so there is a significant deviation from our 52%. So we can just conclude that gender and pet preference are not independent. So that's how you get it from a table. What about a chart? The way you'll see this the most is in a segmented bar chart. A quick review, this is the one where everything adds up to 100%. So how would you look at this? So remember, independence is if the percentage for each subcategory is the same. How would we find that here? We would know that it is not independent if the color slices for each bar are not about the same size. So you can immediately tell that here, this bar over here has a significantly greater proportion of yellow than the other ones, which means that whatever these two variables are, they're not independent. Then what about if we only had these two bars over here, the middle two? These two orange pieces actually look very similar in size, so if we only had these two, we would be able to say that maybe the amount of orange in each bar chart should be independent of each other because they're about the same size. But if there's a really, really big difference in subcategory size in a segmented bar chart, then we know that it is not independent. Because if it is independent, it shouldn't matter which bar we're in, the percentages should stay about constant. So that's it for today, guys. Thanks for watching. Peace.